Hi friends, today I'm Sachin Malhotra. Today I'm going to be solving homework 7 for EL6303 problem 1. In the problem we are given the PDF as B for x square plus y square less than equal to 1, that is a circle with radius 1 and center at 0 0 and 0 otherwise. So first we have to calculate B so that PDF is a valid joint density function. So we know that the area under circle is pi r square and r over here is 1. So area becomes pi, and we also know that the area under the PDF is equal to 1. So B times pi equals to 1, so it implies B is equal to 1 by pi. In the next part, we are asked to calculate the expectation of various things like such as x upon y is equal to y, that is a constant, x upon y, um, e of y given x, e of y given x, and e of xy. So let's first find out the joint density, the density of y. So that is 1 upon y into dx, and the limits ranging from minus root over 1 minus y square to 1 minus y square. So this becomes 2 upon pi into 1 minus y square whole root, the rooted value. Similarly, we can find this for f of x. That becomes 2 upon pi into 1 minus x square. Now finding for expectation of x, we know that expectation of x equal to x into fx into dx. So this becomes 2 upon pi x into 1 minus x square dx. So this value becomes 0 when we integrate it. So now let's find out the conditional distribution, the conditional density, I'm sorry. So f of x given y equal to y is equal to f joint density of xy upon f of y, so which becomes 1 upon 2 under root of 1 minus y square. Similarly, the joint density of y given x equal to x becomes 1 upon 2 under root of 1 minus x square. So let's find expectation of x upon y. So this becomes x into the the conditional density into dx. So this value becomes 0 again. Similarly, for expectation of y given x, this becomes y into 1 upon 2 under root of 1 minus x square and integrating over y. So this also becomes 0. Now we have earlier calculated expectation of x, and we know that expectation of y is equal to expectation of x is equal to 0 since both of them are symmetric. Similarly, we know that expectation of x given y is also 0, and also expectation of y given x is 0. So let's calculate expectation of xy. So this becomes xy into 1 upon pi dy dx. So this value also becomes 0. Now we have to prove or disprove whether x and y are uncorrelated or not. So the correlation is cxy equal to expectation of x minus expectation of xy minus expectation of x into expectation of y. So for uncorrelated, cxy is equal to 0. So thus expectation of xy is equal to expectation of x into expectation of y, and since all these values are 0, hence they are uncorrelated.